My dear students, in the previous video, we have completed the exercise 2.4. We have solved all the problems in the exercise 2.4 and I give some problems for your practice in the examples given in the topic. Now, in this video, I am going to introduce a new definition. Modulus of a complex number. Modulus of a complex number. Modulus of a complex number. What do you mean by modulus? Modulus means magnitude. Magnitude of a complex number. That means, suppose I will consider an example. Z is a complex number 4 plus 3i. I can consider this complex number 4 plus 3i. Real part is 4, imaginary part is 3. In the Argand plane, this is real axis and this is imaginary axis, y axis, origin. 4, 3, this is 0.4 and say this is 0.3 and yes, this is the complex number 4 plus I3. 4 plus I3, this is the complex number Z. 4 plus I3. And what do you mean by modulus means? This is the distance YZ. Yeah, this YZ is called modulus of Z. Mod Z means distance of the complex number Z from the origin O is OZ, that is called modulus. It is also denoted by the letter R. You complete this right angle triangle. This is parallel to y axis. This distance is 3 and this is 4. O, for example, you can say this as A, OA is 4, OZ is modulus, and AZ is 3. For our convenience, I am giving this letter A. Oh, it's a right angle triangle. A right angle triangle. You know OZ, the distance OZ is mod of Z. That is, mod of Z square is A square plus B square, OA square plus AZ square. It is 4 square OA square plus AZ square. It's right angle triangle by Pythagoras theorem. That is, OZ is distance OZ is mod Z square, OA is 4 square. This is 3 square. So 16 plus 9, this is 25. So mod Z square is 25. So mod Z is root of 25, that is 5. It is nothing but, or mod Z is, mod Z square is 4 square plus 3 square. So mod Z, from this you get root of 4 square plus 3 square. This is the modulus of root of 4 square plus 3 square. This distance mod Z is called root of A square. Suppose this is a complex number, Z is, you can consider by A plus IB. Real part is A. Imaginary part is B. This is B. So or what is it? Suppose z is a complex, suppose z is 4 plus I, 4 plus 3i, then mod z is root of a square plus b square, imaginary part square plus real part square. Suppose again generalized example, if a z is a complex number a plus ib, then mod of z is root of a square plus b square. Root of a square plus b square. This is root of a square plus b square. That is the modulus of the complex number z. So z is a complex number. This is example. This is actual definition. Z is to a plus ab is a complex number. Then mod of z is root of a square plus b square. It is also called by letter r. So modulus of a complex number is nothing but square root of real part square plus imaginary part square. That is that. Suppose z is a complex number x plus iy, then mod of z equal to root of real part square x square plus y square. This is the definition for modulus of a complex number. Okay? Now, one more example. Suppose we consider z by 4 plus 3i. What is mod z? Root of 4 square plus 3 square. That is 16 plus 9, 25, root of 25. That is equal to 5. This is your mod z. Suppose what is the conjugate of that z? Complex number z 4 plus 3i. Conjugate of z is z bar is equal to 4 minus 3. The sign of the imaginary part will be changed for the conjugate of complex number z. Here mod of z bar is what? Root of again 4 square plus b is minus 3 square. Again you have 4 square is 16 plus minus 3 root square is 9. Again this is 25. Again root of 25 is 5. So mod of z bar is also. So from this I get on result mod of z is equal to mod of z bar. So modulus of the number and the modulus of the conjugate of the complex number are equal. So now generalizing. So generalized definition z is a plus ib, a complex number. And what is mod of z? Root of a square plus b square, you know. This is the modulus of the complex number z. And its conjugate z bar is a minus ib. A minus ib. What is the modulus of the conjugate of the complex number z? Mod of z bar is again equal to root of a square plus minus b the whole square. It's again b square. Therefore, a square minus b square is b square. So, mod of z and mod of z bar, modulus of z bar are same. Mod of z equal to modulus of z bar. What is modulus of z square? Mod of z square, root of a square plus b square, the square. Squaring and square root vanished, you get a square plus b square. So modulus of z square is a square plus b square. What is z into z bar? Z is a plus ib, z bar is a minus ib. So a plus ib into a minus ib is a square plus b square. So from these two I get mod of z square is equal to z into z bar. Mod of z square is equal to z into z bar. Modulus of z square is a square plus b square. Z into z bar is a square plus b square. Therefore, mod of z square is z into z bar. From this, taking square root on both sides, mod of z equal to square root of z into z bar. You can consider this as well here. Deduction from this, mod of z square, z into z bar is taking square root on both sides, mod of z is square root of z into z bar. Now we are going to see the properties of modulus of a complex number. That's our next idea. Properties of modulus of a complex number. Properties of modulus of a complex number. First property, mod of z is equal to mod of z bar. Just we have derived mod of z equal to mod of z bar. Second one is mod of z square is z into z bar. Third one is mod of z is square root of z into z bar. These are properties. And fourth one is mod of z1 plus z2 is less than or equal to mod of z1 plus modulus of z2. Mod of z1 plus z2 is equal to modulus of z1 plus modulus of z2. This is called, the fourth property is called triangular inequality. Triangular inequality. The third property is called, this is called triangle inequality. Triangle inequality. Mod of z1 plus z2 is less than or equal to mod of z1 plus mod of z2. Fifth one is modulus of z1 into z2 equal to modulus of z1 into modulus of z2. We can product, modulus of the product is equal to product of the moduli. Moduli is a plural for modulus. This is fifth one. Mod of z1 into z2 is less than or equal to mod of z1. Sorry, equal to mod of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. Fifth one is product of the modulus is equal to modulus of the product. This is mod of z1 into z2. Sixth one is modulus of z1 minus z2 is greater than or equal to mod of mod z1 minus mod of mod z2. This is the property. Modulus of z1 minus z2 is greater than or equal to modulus of z1 minus mod. Okay, seventh one. Modulus of z1 by z2 is equal to modulus of z1 by modulus of z2, where z2 is not equal to 0. It should not be 0. Z2 complex number is not equal to 0 complex number, means 0. Mod of z1 by z2 is equal to mod of z1 by mod of z2. And eighth one is real part of z is less than or equal to mod z. Real part of z is less than or equal to mod z. Ninth one, imaginary part of z is also less than or equal to mod z. I will explain these two properties later. And tenth one, modulus of z power n equal to mod of z power n, where n is an integer. You remember these 10 properties. using these properties, we are going to solve the problems also. And how we get this real part of the listener harmonic, we will see. For example, from the example only, I will explain the property. 8th one. Suppose you consider the complex method by 4 plus 3i, just we have taken. Mod of it is, root of 4 square plus 3 square, that is 16 plus 9, 25, that is 5, So, the real part of z is what? 4. Mod of z is 5, therefore, real part of z is less than or equal to mod of z. So, mod of z is 5, real part of z is 4, therefore 4 less than or equal to 5, that means 4 less than 5. When it will be equal, if it is the case, suppose imaginary part is 0, you will get 16, 4 only, then that is the case, real part of z should be equal to mod of z when the imaginary part is 0. If 3 is 0, you will mod of z is also 4. In this case, they become equal. Now, the concept wise it is real part of z is less than or equal to mod of z. Similarly, imaginary part of z. Imaginary part of z is what? 3. So this is also less than or equal to mod z. Because imaginary part of z is 3. 3 also less than or equal to 5. 5 is greater. In the case, if it is real part is 0, then mod of z is 3. In this case, the imaginary part should be equal to mod of z when real part is 0. So these two results, suppose z is a complex number a plus ab, when we conclude that mod z equal to root of a square plus b square, therefore real part of z is a. Real part of z is a should be less than or equal to mod of z root of a square plus b square. Similarly, imaginary part of z b less than or equal to root of a square plus b square. Therefore, these two results you can conclude from this example and by this concept. Okay. These are the properties of the models of the complex number. Then we will go to the exercise problems in the book given as exercise 2.5. We will solve the exercise problems in the next video. Thank you.